Hi there, my name is Andrew Dunkley. Thanks for joining us on the latest episode of Space Nuts. Coming up, we are going to be looking at a planet that looks like Earth and maybe around about the same size as Earth, but it's not Earth and it's not even in our solar system. But it's very exciting and it's an Australian discovery. Also, the search for potential alien objects, as in megastructures or Dyson spheres. We've had questions about those in the past. And space noise could be a threat to the Square Kilometre Array. That's all coming up on this episode of Space Nuts.
15 seconds. Guidance is internal. 10, 9. Ignition sequence start.
Space Nuts.
5, 4, 3, 2. 1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
Space Nuts.
Astronauts report it feels good.
And joining us to sort all of that out and plenty more is Professor Fred Watson, astronomer at large. Hello, Fred.
Andrew, it's great to see you, except I'm not seeing you today, but it's great to hear your voice.
It's cameras off to conserve bandwidth. That's what we're trying to do.
Exactly.
Yes. Otherwise, if that doesn't work, we'll just have to yell.
Yeah, that might be the last resort, I think.
Yes, the internet's a wonderful thing when it works.
Indeed it is.
Yes. How's Sydney? How's everything in Sydney? I should know because my boys live there, but they don't tell us anything.
Well, speaking on behalf of your boys, it looks pretty good at the moment. It's a beautiful day, actually. Yeah. I took the dog out for a walk this morning and enjoyed the sunshine in the dog park. It was great. So it's
lovely.
A nice day.
Yes.
Yeah.
We've had some beautiful weather out here lately. It's just been very mild and sunny, and my solar panels are doing a great job. So everything's nominal.
Nominal, that's
and that too. Fred, let's get on to our first topic. This one I spotted in the news the other day, and I just thought we've got to talk about this because it's something that we've discussed before, the discovery of exoplanets, and they say, we've found an Earth-like planet, and then when we talk about it, it's actually not really that much like Earth because it's too big. But now it appears they have discovered an Earth-like planet, and it's not quite as big as Earth, but it's pretty darn close. And it could also be in the Goldilocks zone. This all sounds very exciting.
I think it is. And it's a very nice story. It's an Australian-Scottish story because the two scientists involved with this, one is based at the University of Southern Queensland here in Australia. The other is at my old alma mater, the University of Edinburgh in Scotland, and they have collaborated on this discovery. So it's a planet that is, as you said, it's near. It's 40 light years away, and that's quite an important aspect of it because it means that before too long, when we get into the era of extremely large telescopes, of which one is on the stocks at the moment down there in Cerro Amazones in Chile, we might be able to see an image of this planet because it's 40 light years is kind of within reach of the imaging capabilities of these telescopes. Of course, you've got to block the light of the parent star off so you can see the planet, but we might get some really useful information about it. But it's a planet around a red dwarf star, and that is in some ways the Achilles heel of discoveries like this, because a red dwarf star is one that is cooler than the sun. In fact, most of the stars in our galaxy are red dwarf stars. It's by far the most common star in the galaxy. And whilst they emit radiation at rather longer wavelengths than the sun does, so it's infrared rather than, or a lot of it's in the infrared rather than the visible spectrum. What they also have is solar flares. They are a bit, perhaps, mean in the sense that they spit out radiation from their surfaces, a bit like the sun does, but rather more aggressively than the sun does. The star is called Gliese 12. It's from Herr Professor Gliese's catalogue of red dwarfs that goes back a long, long way. And so, of course, the planet is Gliese 12b. And its orbital period is, if I remember rightly, it's just a few days, 12 days it takes. That's its year. And because it's at that Goldilocks zone distance, it has a surface temperature which is estimated to be around 42 degrees Celsius, which is warmer than Earth. We are at an average of 15 degrees Celsius. 42 for an average temperature is still within the region that the water wouldn't boil away, that you would have possibly liquid water if the water is there. So a really enticing and interesting object.
Yes, it is. And liquid water is what we're looking for. We're looking for planets in that zone where they could have oceans or rivers or lakes or whatever on the surface. This one runs at a temperature of 42 degrees Celsius, which is a bit hotter than our average. It's about double our average, I suppose. But that would be tolerable for humans, that kind of temperature. We'd acclimatise to that pretty reasonably, I think.
That's absolutely right. It would be something that, if you had a species on the planet that had evolved in a similar fashion to the Earth, you could evolve over millions of years to cope with temperatures like that. So yeah, it is really an interesting object. I've just lost my crib sheet on this. The page that I was looking at on the web, which I might just add, is the Guardian. The Guardian, of course, that very well-known news channel. I've probably told you this before, and I shouldn't joke about the Guardian, but I will. Back in the day, when it was print only, in the days of before the internet, this is a long time ago, Andrew. You'll remember it though. The Guardian was famous for its typographical errors, and you sometimes found paragraphs upside down and things of that sort in the Guardian. So we all called it the Groniad because it was a typo in the title, the Groniad. Now, hats off to the Guardian for this report. Because I'm going to give a shout out to the PhD candidate from University of Southern Queensland, who's the co-discoverer of this planet. His name is Shishir Dholakia. I hope I'm pronouncing that correctly. He is going to be a future star of science communication. There is a short video clip on the Guardian's website in which Shishir talks about this discovery, and I think he is a phenomenal science communicator in the making. It is a very, very nice little video clip, and I think that might be a name that we should keep in our minds as a future science communicator.
Yes, very good. The other exciting thing about this discovery planet, Fred, about this planet is you said it does an orbit every 12 days. If you move to this planet and live to the average human age, you'd live to be 2,433.
Nice calculation there, Andrew. Yep. That's probably right, too. That's a good age for a Gliese 12b inhabitant. 12,000.
Yeah. But it sounds like you'd also get a fabulous suntan.
Yes, you might get the occasional burst of subatomic particles as well, which might not do you much good.
Yes, if you want to look up that story, as Fred said, it's on the Guardian website, and if you just search for potentially habitable planet-size Earth, you'll find that story. Fred, I did want to. I was going to leave this till later, but let's do it now. There's another story in the news at the moment that caught my eye, and that is something we've talked about before: the Square Kilometre Array, which is now under construction. But the concern is noise, satellite noise. That's starting to become a bit of a worry for this radio telescope that's going to be fabulous unless it can't do its job properly.
So this is a bit of a hoary old chestnut that you're raising here, Andrew, and you're talking to the right person, because this is the topic that took me to the UN in Vienna last year to discuss exactly this, the issues of satellite interference on both radio and optical telescopes for astronomy. And it is correct that we are talking about the possibility of tens of thousands, possibly even 100,000 satellites in low Earth orbit by the end of the decade. They are the most notable numbers are the Starlink satellites, which are being launched by SpaceX, of which there are about 5,500 currently operational. SpaceX has got permission to launch about the same number again to bring it up to nearly 12,000, but also with applications in for a further 30,000. And we've known for a number of years that comes with penalties. Now, the particular article that you're talking about is written by a journalist who I think really wants to make the point that if you're spending $3 billion on infrastructure like this, and it's an international venture, it is going in Western Australia, which is one of the most radio quiet regions on the planet. You want to make the very best possible conditions, and that is absolutely true. But the point that it's made in some of the interviews in that article, I read it yesterday, that astronomers and the industry are working together to try and rectify this issue, because it's recognized as a problem. There is now an International Astronomical Union Centre. We usually call it the CPS, which is short for the Centre for the Protection of the Dark and Quiet Sky from Interference by Satellite Constellations, which is a bit of a mouthful. So the CPS is actively engaging with the industry. There are actually industry people on the CPS itself, some very, very able space engineers who recognise that there is an issue. It is part of Starlink's policy to switch off their transmitters when they go over radio observatories. So there's no risk of them beaming down directly into a sensitive radio antenna. And I think the problem is the noisy electronics of these spacecraft. So the spacecraft themselves, even when they're not beaming down energy to the ground, which they aren't when they're passing over radio observatories because they're switched off, they are noisy. They're electronically noisy, and the telescopes are so sensitive that they can detect that. And radio astronomers are absolutely right to be very, very concerned about this. The other thing about
the location that was chosen for the Square Kilometre Array in Australia was chosen because it was supposed to be a quieter zone. But the way things are going, it won't matter where you are.
That's right. In that regard, you've got this background, but it's not true to say it won't matter where you are, because you've got to be away from terrestrial transmissions. You've got to be as far away as you can
of course.
From those, because they are the thing that really swamps you. The electronic noise from satellites is orders of magnitude less than what you'd have if you were right next to a city full of mobile phones and microwave ovens and things of that sort. So you still need to be in outback Australia, or as the other half of the Square Kilometre Arrays in South Africa and the High Karoo there, where SKA mid, which is the mid-frequency arm of the Square Kilometre Array, you still need to be there. But it is absolutely true that you've got this now. We have this background that comes from space, and it's from human-made radio noise. The point I was going to make is that Starlink is very engaged with this issue. SpaceX, there's no question of that. Other players such as Amazon, which is launching another constellation of satellites, which is called Kuiper, they too are engaged with this issue because they're taking the lead really from Starlink. And I think as time goes on, we'll find that the spacecraft themselves are much less noisy. They've got a relatively short lifetime. A Starlink satellite will remain in orbit for 5 years, and then it'll re-enter and burn up, to be replaced by a later generation model. And it's likely that these later generation satellites will be much less electronically noisy because of the work that's being done and, coordinated by organizations like the IAU CPS, the Centre for the Protection of the Dark and Quiet Sky from Interference by Satellite Constellations, to give it its full name. So it is a doom and gloom story if you want to make it that, but it also has a lot of hard work going on in the background to rectify this situation because, companies like SpaceX recognise that there are huge investments in ground-based astronomy, radio astronomy, and optical astronomy. So they are, they're being good, basically good citizens by responding to that.
Oh, that's good to know. Yeah, I suppose it's not unusual though for the commercial needs of the world to conflict with the world of astronomy or any other area of study. So being able to take a cooperative approach to it and find ways around the problems is always a good thing, and it does sound like that they've taken that into account. And we see that in other areas with observational astronomy and cities like the one I live in, changing their street light systems to keep the light pollution at the lowest possible level. So there are good things happening in that regard, and let's hope that this one doesn't become too big a problem when you're spending $3 billion in outback Australia. So
I think it's actually a bit less than that. I think it's probably just under $2 billion altogether. But yes, it's a lot of money. It's a lot of money.
It is indeed, yeah. All right. If you want to look at that story, the ABC website in Australia, abc.net.au. This is Space Nuts. Andrew Dunkley here with Professor Fred Watson. Let's take a quick break from the show to tell you about our sponsor, NordVPN. And a virtual private network is something that a lot of people use these days to protect what they're doing online from scammers and hackers and anybody else who wants to download your information and sell it on the dark web, which has become all too common. There's a story recently about millions of people who bought tickets online, having all their data now available for sale on the dark web. It's pretty terrifying stuff, isn't it? Of course, identity theft is another big reason that people get hacked, and it just goes on and on and on. So how do you protect yourself? Well, the first line of defense is a virtual private network, and there is none better than our sponsor, NordVPN. And as a Space Nuts listener, there's an exclusive and special deal for you, including a 30-day money-back guarantee and an extra 4 months just for signing up. That's 4 months extra for a 2-year deal, 3 months extra for a 1-year deal, or you can go month by month. So all you have to do is go to the URL that's been set up for you, nordvpn.com/spacenuts. That'll bring you to an introduction page where you can click on a button that says Get the Deal. And once you're in there, you can look at all the products that are available, not just the virtual private network, but the other products, depending on what level you want to go. Now, if you want to stick to the basic service, that's fine. You can get high-speed VPN, and you can secure 10 devices at once. 10. So they've upped the ante on that. And you can then increase what you consider to be useful to you under the different packages that are available. I've got everything. My favourite of all is the cross-platform password manager. This is a really great product, and I've talked about it many times. And it's basically a way of storing all your usernames and passwords for all the online things that you need to get into, from your bank accounts to your email accounts to the password on your doorbell or whatever it is. You can do it all, and all you have to remember is the master password, one password to get you into the password manager, and then you can find what you want. And if you set it up properly, you can also log into all your respective web pages and bank accounts and all that kind of jazz straight through the password manager. Very, very clever, very simple, very useful. And let's face it, we've got so many user names and passwords these days, it's pretty well impossible to remember them all. What a lot of people do is use one password for everything. Not a good idea. But you can find out more at this URL, nordvpn.com/spacenuts. Check out their prices, check out their packages, check out what you need, and go accordingly, because the longer you sign up for, the lower the price gets on a monthly basis. But very much worthwhile, and an extra 4 months on top of whatever package you buy over whatever time frame. So a great deal for Space Nuts listeners. nordvpn.com/ Space Nuts. Have a look today and get the deal. Now, back to the show.
0G, and I feel fine.
Space Nuts.
Now, Fred, to a story that has come up before, and we get occasional questions for our Q&A version of the show on this very topic, and that is Dyson spheres or megastructures in space. And, well, I guess to give you the short version of what's going on, the search is on to see if we can find any of these.
Absolutely right. That's right. And so this is basically come up as a story because there's been an op-ed piece written by Simon Goodwin for The Conversation, and it's about why Dyson spheres probably don't exist. And Simon starts off with I think it's a lovely opening paragraph, which I'm going to read. It's you can find it on The Conversation, or it's also on phys.org, one of our favourite science news websites, phys.org. So Simon starts off, there are 3 ways to look for evidence of alien technological civilizations. Actually, there's more than 3, I guess. There's more than 3. But I'll add my 10 penneth as well. There are 3 ways to look for evidence of alien technological civilizations. One is to look out for deliberate attempts by them to communicate their existence, for example, through radio broadcasts. And I guess that's what SETI's all about. Another is to look for evidence of them visiting the solar system. And a third option is to look for signs of large-scale engineering projects in space. And that's where the Dyson spheres come in. Now, I'm going to put my own 10 penneth into this because I'm going to say another option, and I think this is the most likely way we would find evidence of a technological civilization, is to look at their pollution, what they're doing, either in terms of polluting their atmosphere with chemicals that can only be created by industrial processes, which we've done here on Earth, or to look for signs of, radio broadcasts that are leaking into space, things of that sort. So the sort of accidental evidence that there is a technological civilization there, which is actually what anybody looking for life on Earth would have to find, because that's the thing that betrays that there is technology on Earth from our own planet's perspective. Things like CFCs in the atmosphere, things like radio signals leaking out past the ionosphere and into the depths of space. Anyway, enough of that, because this is really about Dyson spheres. And essentially, there is some research that has been done, which is actually published in one of the most prestigious journals in astronomy, Monthly Notices of the Royal Astronomical Society, where they've looked through astronomical survey data to try and find something that might be a megastructure. So these are, these are stars, and again, they're red dwarf stars like we were talking about a few minutes ago, all within 1,000 light years of Earth, because that's where you can make the best measurements. And what they've done is they've looked for a kind of infrared signal from these. So let's just talk about what a Dyson sphere is, proposed by Freeman Dyson, the very well-known physicist, back in 1960, actually, as a way of harnessing the power of a star and turning it into electricity. And so what you do is you put all these power collectors in orbit around the star, and you get them generating electricity, and then eventually you build it up into a sphere the size of the star. It's surrounding the sphere, the star. Sorry, the sphere is surrounding the star, hence the name of Dyson sphere. And they would have a signature, an observable signature, because while the visible light is collected by the solar panels that are on the star-facing side of the megastructure, the other side is getting hot because they're absorbing visible light, and they're getting, they're turning some of it into electricity, but they're not turning it all into electricity. And what is remaining is excess energy, and it's infrared radiation with a particularly longer wavelength. And so that could be a signature for the presence of a Dyson sphere. It's also likely to be the signature of a lot of other stuff, which are quite natural, like a protoplanetary disk, for example, a disk of dust and gas, all of that sort of thing. So they basically looked at these and said, okay, these have a long wavelength signature. I think they found 7, is that right, that sort of fit the bill as being oddballs. This is essentially, what they're really trying to write the paper. They've identified 7 candidates. That's what they're using to write the paper, I should say. Sorry, I'm gabbling a bit here. There's so much information to give. I'm not sure what order to give it all in. But the bottom line is that there's 2 parts to this, Andrew. One is that the maths doesn't add up in terms of what you gain. And this is what comes out of this paper, the research paper. If you, and once again, quoting the the conversation piece, which is also on phys.org, a quick calculation reveals that if we wanted to collect 10% of the sun's energy at the distance the Earth is from the sun, we'd need a surface area equal to 1 billion Earths. And if we had super advanced technology that could make the megastructure only 10 kilometers thick, that's pretty thin, really, for something that size. It means that you would need about 1 million Earths worth of material to build them from. And so, the numbers suddenly start making no sense whatsoever. They go on to point out. Sorry, go on. Yeah, go on, Andrew.
Yeah, well, look, there's plenty of Lego blocks around. I think we've already got enough.
We might have enough Lego blocks, but they're not known for their photoelectric properties, I have to say. If you attach a couple of wires to a Lego block and put it in the sun, you're not going to get much electricity out of it. Yeah. That's the bottom line.
Yeah, but they're working on all these new things that you can paint on. So maybe we paint the Lego blocks.
That's certainly true. That is certainly true. Anyway, I won't go on with the details, but you just need far too much stuff. You need 1 million Earths worth of material to build your Dyson sphere from, and it turns out that the solar system only has about 100 Earths worth of solid material. So, you've got to, as they say, you've got to dismantle all the planets in 10,000 planetary systems and transport it to the star to build a Dyson sphere. I mean, it doesn't make sense. And there is one other aspect to it.
Doesn't add up.
That's right. There's one other aspect of this that I think is important, and that is that back in 1960, when Dyson proposed the Dyson spheres, we had a history of humankind getting more and more energy hungry, and the more energy, as time went on, looking back from the 1960s, and you plot the amount of energy that is used by our planet, it was going up sort of exponentially. And so if you follow that graph into the future, then yes, you are going to need, huge reserves of power to satisfy an energy hungry civilization. But that's not what's happened. Since the 1960s, we've learned how to do things with much, much less energy, much more frugal use of energy. And so as we have progressed as a species, humankind, our energy needs have not kept on going up in the way that Dyson thought they would. And actually around the same time, an astronomer called Nikolai Kardashev, who proposed a scale of civilization which depended on their power consumption. So things have changed. And I think the Dyson sphere idea really doesn't hold water these days. I think it's something we should really forget about. It's not there. It's not going to happen.
We're probably better off putting our efforts into researching renewable energies, which we're doing through solar and wind and all that. But maybe fusion energy, that might be the future.
Yes, if you do have huge energy needs, and they are increasing. It's certainly not true to say that our energy needs aren't increasing. They are, but not in the way that people like Kardashev and Dyson thought. So yes, sustainable energy, natural sources, nuclear fusion, whatever the future holds, which will hopefully make sense for a species that is increasing in wisdom about how we use these things and how we generate them, perhaps.
Well, let's face it, Fred, if any species within 1,000 light years put a telescope on this planet, they go, oh, yeah, no, that's filthy. We're not going there.
Don't like the look of that. Very grubby planet.
Yes. They didn't get it right.
No,
that's a mess.
It's a mess.
Yeah. Look at all those satellites. My goodness. Although that could look like a megastructure from a distance, couldn't it? All those satellites around the planet.
Only if you had a very, very good telescope. I mean, essentially, if you look at the Earth, even from the distance of Mars, you don't see any of that. The satellites are far too small to reveal themselves. The radio interference might be what gives it away.
Yes, indeed. Okay, if you want to look at that Dyson Spheres story, you can go to phys.org or the Conversation website, both fabulous places to read well-researched and fully factual information. They are very highly reputable sites, and we adore them. Fred, we're just about done for this episode. Just a reminder to everybody, if you want to chase anything up, don't forget to go to our website, spacenutspodcast.com or spacenuts.io. And if you follow us on YouTube, don't forget to subscribe. We really appreciate that. And I haven't mentioned it for a while, but reviews. If you can do some reviews, that's always helpful on whatever platform you use. Leave us a review. And, we'd really appreciate that. It gets more people involved, and don't forget our social media platforms as well. Fred, that wraps it up. Thank you so much.
It's a pleasure, Andrew. Good to chew the fat over all these scientific issues. Always a pleasure.
Indeed. All right. Professor Fred Watson, astronomer at large, and from me, Andrew Dunkley, thanks for your company, and thanks to Hugh in the studio, who has developed this incredible ability to attain invisibility. Can't see. Until next time, this is Space Nuts. We'll see you on the next episode. Bye-bye.
Space Nuts. You've been listening to the Space Nuts podcast.
Mission complete, Houston.
Available at Apple Podcasts, Spotify, iHeartRadio, or your favorite podcast player. You can also stream on demand at Bytes.com.
This has been another quality podcast production from Bytes.com.